Welcome to Grade 11 Math Comprehensive Review Part 1. Hope you have your pen and paper ready. Let's start by simplifying the expression, the square root of 50 plus the square root of 18 minus the square root of 8. To simplify the expression, we start by breaking down each square root into its prime factors. First, the square root of 50 equals the square root of 25 times 2, which is the square root of 25 times the square root of 2, giving us 5 times the square root of 2. Second, the square root of 18 equals the square root of 9 times 2, which is the square root of 9 times the square root of 2, giving us 3 times the square root of 2. Third, the square root of 8 equals the square root of 4 times 2, which is the square root of 4 times the square root of 2, giving us 2 times the square root of 2. Now substituting these back into the expression gives us 5 times the square root of 2 plus 3 times the square root of 2 minus 2 times the square root of 2. Combining like terms, we get the sum of 5, 3, and minus 2 times the square root of 2, which equals 6 times the square root of 2. Thus, the simplified expression is 6 times the square root of 2. Next, let's try this next question by solving for x 3 times the square root of x equals 12. To solve for x in the equation 3 times the square root of x equals 12, follow these steps. Step 1. Divide both sides by 3. The square root of x equals 12 divided by 3, which simplifies to the square root of x equals 4. Step 2. Square both sides to eliminate the square root. X equals 4 squared, which gives us x equals 16. Thus, the solution is x equals 16. Now, if you want to know how to rationalize the denominator of the expression 5 divided by the square root of 3, here is the solution. To rationalize the denominator of the expression 5 divided by the square root of 3, we multiply both the numerator and the denominator by the square root of 3. This gives us 5 times the square root of 3 divided by 3. Thus, the rationalized form of the expression is 5 times the square root of 3 divided by 3. The fourth question you can try is to solve the equation. The square root of x plus 5 equals 7. What is the value of x? To solve the equation the square root of x plus 5 equals 7, we start by squaring both sides to eliminate the square root. X plus 5 equals 7 squared, which simplifies to x plus 5 equals 49. Next, we subtract 5 from both sides. X equals 49 minus 5, which gives us x equals 44. Thus, the value of x is 44. Let's simplify and rationalize the denominator of the expression, the square root of 5 minus 1, divided by the square root of 2 plus 1. To simplify the expression, we first need to find a common denominator for the terms involving fractions. The common denominator for the square root of 2 is the square root of 2 itself. We can rewrite the expression as follows. Step 1. Rewrite 1 as the square root of 2 divided by the square root of 2. The expression becomes the square root of 5 minus 1 divided by the square root of 2 plus the square root of 2 divided by the square root of 2. Step 2. Combine the terms. The expression now becomes the square root of 5 plus the square root of 2 minus 1 divided by the square root of 2. Step 3. The expression is now simplified to the square root of 5 plus the square root of 2 minus 1 divided by the square root of 2. This is the simplified form of the original expression. Next question, use factoring to find the root of the equation n cubed plus 59 equals 5. To find the root of the equation n cubed plus 59 equals 5, we first rearrange the equation to set it to 0. N cubed plus 59 minus 5 equals 0. This simplifies to n cubed plus 54 equals 0. Next, we can express this as n cubed equals negative 54. To factor this equation, we can look for rational roots using the rational root theorem. The possible rational roots are the factors of negative 54. Testing these factors, we find step 1 n equals negative 3. Negative 3 cubed equals negative 27, which is not a root. Step 2 n equals negative 4. Negative 4 cubed equals negative 64, which is not a root. Step 3 n equals negative 2. Negative 2 cubed equals negative 8, which is not a root. Step 4 n equals negative 1. Negative 1 cubed equals negative 1, which is not a root. Step 5 n equals negative 6. Negative 6 cubed equals negative 216, which is not a root. Step 6 n equals negative 3.78. Negative 3.78 cubed equals negative 54.0, which is approximately a root. Since we cannot find a simple rational root, we can conclude that the roots of the equation n cubed plus 54 equals 0 are complex or irrational. The real root can be approximated using numerical methods or graphing techniques. Therefore, the root of the equation is approximately n equals negative 3.78. Third question, the area of a square is 30 centimeters squared. Find the length of a side to 2 decimal places. To find the length of a side of a square when the area is given, we can use the formula for the area of a square, which is area equals side squared. Given that the area is 30 centimeters squared, we can set up the equation side squared equals 30. To find the length of a side, we take the square root of both sides. Side equals the square root of 30. Calculating this gives us approximately 5.48 centimeters. Therefore, the length of a side of the square, rounded to 2 decimal places, is approximately 5.48 centimeters. Let's start with this question. Determine the non-permissible values for the rational expression x divided by 5x minus 1. To determine the non-permissible values for the rational expression x divided by 5x minus 1, we need to identify the values of x that make the denominator equal to 0, as these values are not allowed in the expression. Set the denominator equal to 0, 5x minus 1 equals 0. Now solve for x, 5x equals 1, x equals 1/5. Thus, the non-permissible value for the rational expression x divided by 5x minus 1 is x equals 1/5. This means that the expression is undefined when x is equal to 1/5. Next question to work on is to simplify the rational expression x minus 2 divided by 5x minus 10. To simplify the rational expression x minus 2 divided by 5x minus 10, we first notice that the denominator can be factored. The expression 5x minus 10 can be factored as 5 times x minus 2. Therefore, we can rewrite the expression as x minus 2 divided by 5 times x minus 2. Next, we can cancel the common factor x minus 2 from the numerator and the denominator, provided that x does not equal 2 to avoid division by 0. This gives us 1/5. Thus, the simplified form of the rational expression is 1/5. Last question to try is a word problem. A total of $22,000 was invested at 2 different interest rates that yielded a total of $885 in interest after 1 year. If one rate was 3% and the other 4.5%, how much was invested at each rate? To solve the problem, we can set up a system of equations based on the information provided. Let x be the amount invested at 3% and y be the amount invested at 4.5%. We know the following. The total amount invested is $22,000. X plus y equals $22,000. The total interest earned from both investments after 1 year is $885. 0.03x plus 0.045y equals 885. Now we can solve these equations step by step. From the first equation we can express y in terms of x. Y equals 22,000 minus x. Next we substitute this expression for y into the second equation. 0.03x plus 0.045 times 22,000 minus x equals 885. Expanding this gives 0.03x plus 990 minus 0.045x equals 885. Combining like terms. Negative 0.015x plus 990 equals 885. Now, we isolate x. Negative 0.015x equals 885 minus 990. Negative 0.015x equals negative 105. X equals negative 105 divided by negative 0.015. X equals 7,000. Now that we have x, we can find y. Y equals 22,000 minus 7,000. Y equals 15,000. Thus, the amounts invested at each rate are $7,000 at 3% and $15,000 at 4.5%. If you found this revision useful, please like, share, and subscribe. See you in the next session.